grateful to the organizers for giving me the opportunity to talk about augmenting classroom teaching with AI. And I'm a scientist who is also interested in teaching science. So there are various challenges in teaching science, and these have been documented quite extensively. The first challenge that we have is to be aware that science is a very practical subject. Even if we are dealing with abstract things like theory of relativity or evolution of life, it is all based on some observations and practical exercises. We know there is an aspect of pedagogy where we have active learning as opposed to passive learning or just instructions. And as far as I know, active learning is much more useful approach to learning science. But there are lots of students who would do much better with less engaging or less active methods. And that is where the challenge starts building, because there are linguistic barriers to science and things that can be best learned through from peer-to-peer learning. So language and linguistic abilities are always a challenge. And I myself come from a vernacular schooling, and I had to learn English for science when I was in high school, and it is not easy. And science communication, both written and spoken, is much more different. And finally, we have the fact that science concepts can be very complex and difficult to grasp. So I teach biology, more specifically molecular biology, and much of the concepts in molecular biology are daunting to explain if you do not have background from the field. So we know that molecular mechanisms which govern biological processes are complex, and their occurrence at microscopic scales makes it challenging to grasp. And it is very difficult to imagine how the same DNA in each cell of an organism can give rise to wide range of functional and structural cellular diversity. And to understand the relationship between the DNA sequence and different cell types and the characteristics of the person, it's not very easy for most of us. The genotype to phenotype explanation is the real problem for students to grasp. So we try providing some visual and some contemporary context to the students. And here is a popular take on explaining gene expression using a snapshot analogy to a selfie. And this is a witty cartoon, and it brings the point, it brings the point to home that whatever a cell is, it is basically an expression of the protein. It is the expression of the genes or what proteins are present in the cells at the time. And here I'm taking an example of a fundamental cellular process of protein synthesis in eukaryotic cells. And this cartoon depicts the process of initiation of translation itself. And translation initiation, it ensures that the translation machinery starts or it begins translation from the correct start codon. And if there is a wrong codon is selected by the translation machinery, then there will be a wrong peptide synthesized in the cell, which would be potentially toxic and harmful to the cell. And in human beings, if this translation initiation process is messed up, we can have serious health conditions like cancer and neurological disorders. And this process of translation initiation is best explained by the scanning mechanism in which the translation or the ribosomes move along the mRNA to locate the correct start codon. And once this small ribosomal subunit has reached to the start codon on the mRNA, only then there is a structural rearrangement and the elongation process of translation begins. So we can show the schematics to students using this tool, but there is a dilemma. How do we explain this complicated model in an easy way to students? And I have tried providing the AI-generated text in my handouts or notes to students. The important thing in the text is not to omit any step of the pathway that has been shown here in a picture format and here in a text format. And there are many students who are better at learning visually, for whom this schematics on the left side is going to be much more helpful. But there are many students who would like to go through the steps by reading the text on the right-hand side. And if I need to explain this complicated pathway in short in a classroom to undergrads, I should be able to move across these two uh, scenarios quite easily. And that is where AI has helped me. And now I can move from picture to text or the other way around to make sure that students are able to understand the concept in here. And second is there are challenge of linguistic diversity. Not everyone in class have the same linguistic roots, especially in a country like India, where we have so many different languages. So on the left-hand side, you can see a practice sheet that helps students understand the concepts of prokaryotic and eukaryotic cells. But many non-native English-speaking students would be left out of understanding the concept which is explained on the left side. But on the right-hand side, we have the MCQs shown in Hindi, which most of Hindi-speaking students in India can answer well. So with the help of with the linguistic tools of AI, students can now easily navigate across the language barriers. That is where AI also helps students. And there is another thing that most teachers are asked to do. Can you teach a subject in 30 minutes? Just give us a general idea of what are you teaching. And it can be very difficult to summarize a difficult concept in one pathway or something. And this is where you just ask generative AI that you want to model, in this case, whether it is geospatial data models or anything. So it gives you a very generic models which students are able to comprehend without going into the details of the algorithm for the process itself. So here, generative AI provides a general summarization in a good way. And finally, there is another very common challenge which bench biologists face, and that is how to explain a very long protocol, which includes 100 or 150 steps, to a new student or a person who is new to the field. So how do you go about it? Do you hand over to them a protocol which is like 50-page long so that they have to go through all those 100 steps, or you just try to make it a simpler way where they just can have the idea about it, like how many steps are in there and how long is it going to take them. So so here generative AI helps to kind of break down the intimidation which new beginners to the field can feel about the protocol. Oh, this is so long protocol, I'm not interested in learning that. So I have shown with 4 example where AI comes handy in solving those challenges. However, there are many more results that we have seen in the classroom, which are results of using AI. AI tools, I mean, we have listened to previous speakers and they have also mentioned about it. AI tools help students plagiarize very comfortably, and turning in an AI-generated modified essay is very easy, and it is sometimes very difficult to identify the malpractice. And the richness of the knowledge seems to be kind of lost over. Everything seems to be a black box, and it seems that ChatGPT knows everything. So we do get this deja vu kind of feeling when we had started using the internet and Wikipedia for our questions. But just like the false information on the web, we know that AI, especially the large language models, they hallucinate and they also have model biases. And we also have to remember that our learning experiences are very broadly connected. Situated learning of scientific concepts have always been discussed to be much more wholesome. Embodied experience of force, pressure, and all those concepts is far more understandable. And finally, we have these generic questions that use of AI comes with. The ethical and social context, privacy and fairness questions, transparency and accountability. Who is accountable if a teacher provides an AI-generated handout with a faulty concept? This is much more common than what we think, perhaps. And I came across this interesting quotation from this reference over here. And it says that most of the negative experiences with AI systems come from students' unrealistic expectations and misunderstandings about the AI systems. And today we have plenty of tools to choose from, and every day we have a new tool for our that can be integrated into our classroom settings, but we have to be careful about the tool that we want to use in our curriculum or in our classroom settings. So what is the next? I feel that we can use AI for all the routine but compulsory part of the learning experience, such as handouts, translation, or summarization tasks, so that we have much more time for curiosity-driven learning. But we have to keep our expectations real. With the use of AI, we can expect much higher efficiency and better insight. And students have to work with AI in real world. So we have to use the best of tools and knowledge. We have to equip our next generation with the skills needed in a knowledge-based world. And thus, AI has to be a part of the learning experience. However, we also have to keep the costs in mind. Things such as accessibility or over-reliance on AI can be very high cost to pay. And then there is the chance of occasional potential misrepresentation when we are using AI. So the way forward is from here is there is a pressing need for more research in pedagogy about the use of AI, especially in teaching science. We know that the positive outweighs, but we also know the challenges, at least some of the challenges. The uncharted territories of what it means in terms of social and interpersonal skill developments. We do not know what is the long-term implication of use of AI or on our natural intelligence, whether we will become dumber if we use more AI. That's something we will figure out in the next 10 years. Will we get worse in terms of explaining scientific terms to multicultural societies? Only future will tell. In our capability to validate a scientific principle, to question our observations, to find something new, whether our over-reliance on AI will dampen our natural curiosity. We don't have data for that. So more importantly, AI is changing day by day, and we do not know what it will bring next. New knowledge, new technology, and new solutions. And finally, we are still to bridge the digital divide in societies, and we may have an even bigger divide, those who can leverage AI and those people who cannot leverage AI. So in summary, classroom teaching is often a challenge for science teachers in terms of understanding the level of concepts that are known by the students. AI provides opportunity to provide reading material and handouts and relevant exercises, as the previous speakers have mentioned. And there is a positive correlation between integration of AI and enhanced academic success. Effective utilization of technology for non-native explanation or in multiple languages can be facilitated by large language models. But most importantly, we are going to see major changes in classroom teaching with AI, just like life in general. So, thank you for your time.
Thank you, Neelam. We have time for a couple of questions. While we wait for audience to post their question, I have just a comment, like something from your previous slide about how the society will be divided. Because one thing people do not pay attention is like AI usually like the source, right? The data was scraped from the internet, while the most high quality resource sometimes are behind the paywall. So basically, like, when they get the training set, oftentimes they get it all over the place. Those free information, false information is like propagated into this, machine learning system. while the most
Yeah.
high quality information stored in very high quality data warehouse or like well-maintained places like OneBase or Alliance of Genome Resources, like with manual curation and validated by scientific curators, they are not easily accessible. So like, with more and more reliance of AI, you can see like these high quality information sometimes get suppressed in this AI system, while those low quality information get like, spread out in the society. And I see
Right.
that a problem because, because that's how the training set was developed, right? So I see that a problem. Do you have any comment about this? Like, do you want to raise this concern to students, like when they use AI?
So I think the idea would be when we are trying to develop those training sets, we have to ensure that it has to be balanced in terms of the data that they are training on. Because if we just go by what is out there, you are bound to get, as you rightly mentioned, that there are sometimes not, how to say, the high quality data is hidden and you have poor quality data or statements out there. So I think I don't know how do we address this, because our data set or all the generative AI models are dependent on easily accessible data in terms of, that is what we do right now. So I don't know how do we negate that. Maybe you have a comment that I can kind of convey to my students if you have something to add in there. Yeah.
Yeah, I just feel like, students definitely need to do more AI independent research to see something not incorporated into the AI training system, because you can really change the training set of ChatGPT, right? You have no power to influence them. So what they want to use as a training set. So I think students definitely should do something completely AI independent to find out how, is that different. Yeah. So yeah, we have a couple of questions. Just really quick, because I think we need to wrap up in 4 minutes. I think, yeah, Marcus Olivia asked like, how can we increase the quality of information we can get from AI tools as raw information is not referenced?
I think you kind of addressed
Yeah,
that point right away.
But I heard some words from some professors that they believe that the future AI will be able to get a reference, because that's something doable. It's that like it's very time consuming, energy consuming. So I would not be surprised if in the future they will give you the reference. And also Tom Manella asked like, as different AI providers ultimately bid for and get exclusive access to different higher quality paywall content, different AI platform will have different levels, efficacy of different disciplines, could end up being quite a mess. So that's very interesting.